I would like to kind of just go through briefly an introduction to first into naturopathic medicine and what naturopathic doctors do, and then I'm going to go into kind of a review of the digestive processes and how the digestive processes work, how the elimination works, how the liver is involved, what sorts of things can go wrong, the signs and symptoms that you can look for, as well as some of the testing and treatment methods. So there's a fair amount to go through this afternoon, and I hope everyone finds something fairly useful here. We'll be taking questions, of course, at the end of the presentation, and yeah, there's a lot to go through. So before I get into the detail of all of this, I'll just explain a little bit about what naturopathic medicine is. A naturopathic doctor is trained similarly to a medical doctor, the main difference obviously being that we use natural therapies instead of drugs, but more importantly, naturopathic doctors try and treat causes of problems rather than symptom chasing with the natural alternative to a drug. Now, autism is probably one of the premier examples of where naturopathic medicine really excels, naturopathic and biomedical medicine, because autism is one of those conditions where you can't find just one drug or the natural alternative to that drug to treat autism, and it's not going to cure absolutely everybody. Autism is a massively, and the spectrum disorders in general, are massively integrated concepts. So there's a whole bunch of things going on in autism or the spectrum disorders that cause the problem. And I'm going to be focusing on a lot of top and work down. This is pretty simple. Actually, it's not. When it comes to digestion, a lot of people forget that there is a large amount of digestion that happens in the mouth. The mouth is responsible for literally breaking up all those large protein molecules. Red meats especially, and various other proteins that are very, very, very difficult to digest must start digestion in the mouth. If they are not properly chewed, they will go into the bowel, and especially with spectrum disorders, they'll go in and rot, and they will putrefy, and they will start causing metabolic waste to build up and toxicity to build up and those kinds of things. Red meats and most proteins are digested almost exclusively, or very large portions of them are digested upper level, in other words, within the mouth. The stomach is not a thrashing machine. It's not some kind of wrecking machine that's going to cram everything together and everything is going to get all brutalized and torn up. That's what the mouth is for. So it's very, very important to spend some time thinking about actual mastication and chewing and how much the proteins are being digested there. Protein digestion must start in the mouth. That's vital, vital, vital to know. There's a little bit of protein digestion in the small intestine. The stomach kind of takes over from the mouth when it comes to protein digestion, but protein is digested in the mouth. You've got to think about that. The stomach is the gentle mixing area. That's where, after you've ground up all of the fibers and proteins and all of the stuff in the mouth, then the stomach is this nice area where things are gently mixed. Again, it's not a thrashing machine where everything is torn up and ground apart or anything like that. The stomach just kind of mixes everything together, adds some acid, and starts to denature those proteins a little bit more. If you're looking at a solid piece of red meat or even something not as difficult to digest, but let's say even a piece of chicken. If you take 3 chews and drop a piece of chicken down into your stomach, it's going to rot. There's no way that piece of chicken is going to digest, especially if you have an autism child. So the stomach, it just kind of mixes everything and just kind of gets all of the acids spread out onto the proteins that you've already broken up with your teeth. Small intestine, at that point, once something goes past the stomach, it gets into the small intestine. That's where all the pancreatic enzymes, the liver enzymes, and the gallbladder enzymes start to take effect. Again, by the time it hits the small intestine, it better be broken up. It better be completely destroyed and ripped open, and everything has to be completely opened up. Otherwise, you're going to have a very difficult time getting the enzymes in this liquid medium into those proteins to digest them further and then have them fully, completely absorbed. It's very, very important. I know I've said it a few times now. Chewing those proteins is vital. Large intestine, for the most part, is yes, elimination is vital component to the large intestine, but the large intestine is also extremely important in the absorption of water and fluids. And often if the large intestine isn't working properly, or diarrhea is happening or something like that, the patient, especially in the autism spectrum, can get severely dehydrated. So it's important to know that large intestine function is more than just physical elimination of the bowel mass. It's got to do with the absorption of waters and various other nutrients that I'll go into in a few moments here. Detail. Let's go into a little bit of detail on the small intestine. The reason I chose this picture here was to show you that the small intestine itself is not a lead pipe. Okay, it's not this perfectly smooth red pipe. The small intestine, if you look at this picture nice and closely, the small intestine has folds upon folds upon folds upon folds. And you can see these folds here. Let's see if my pointer comes up. Yeah, it's not cooperating. But you can see the folds in the small intestine. We call them villi. Then there are further folds upon those folds. Now this is a nice rubberized picture of what the small intestine looks like, but my point is that the surface area of the small intestine is not determined by its actual physical size. You've got these folds and spreads and other folds that the small intestine is made up of. It's in these areas that actual absorption happens. So if there's any damage to these folds, and that happens in leaky gut and inflammatory bowel diseases and a few other things that I'll be discussing in a few moments. But if there's any damage to these folds and these villi and microvilli or anything like that, nutrient absorption is going to be highly, highly compromised. And it would depend on where in the small intestine that damage is. So for example, in the upper small intestine, we call that the duodenum. Various things are absorbed in that area, specifically iron, calcium, magnesium. Those are the top minerals that are absorbed in that area, in the upper small intestine, the duodenal area. If you have damage or inflammation or some kind of leaky bowel in the upper duodenum, you will have iron and calcium and magnesium problems. That was why years ago when Rimland was first doing autism treatments back in the late 60s, magnesium B6 was one of the top treatments, because the amount of inflammation that happens in the upper GI, in the upper small intestine, the duodenal area in an autism child is massive, and therefore the magnesium deficiency is also often very pronounced. So it's vital to know what nutrient is absorbed where in the small intestine, and then you can kind of figure out, well, what nutrient would the child be deficient in, and then be able to give them the right nutrients. Iodine itself